Hello, let's continue our Sudoku adventure with DNS Lookup by Gene. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have W sums. That's these arrows here. So the way these work is the clue inside the arrow is a sum. Now, what is it summing? Well, whatever this digit happens to be, say this was a 3, then we would count 3 cells here, 1, 2, 3. And that's how many cells we would use to try to sum to 12. So maybe 2, 4, 6. Right, 2 plus 4 plus 6, that is 12. And this 3 is telling us to use 3 digits starting from that arrow. So the base of the arrow is the digit that tells you the count. And then starting from the head of the arrow, we use that count of cells to sum to the clue inside the arrow. All right, now keep in mind that these arrows go off the grid. We can't type the digit outside of the grid, but you can imagine what that digit would be in order to fulfill the clue. And when we do so, that digit acts also as a numbered room clue. So for example, this 4, maybe the clue outside here is a 2. Now I can't type a 2, but imagine a 2 is there. Then we would use 2 cells starting from the arrowhead to add to 4. So maybe 1, 3. But this clue outside the grid, that 2, is also a numbered room clue. I'm going to swap these. That clue outside the grid is actually a numbered room clue. And so imagine a 2 there. So this 3, the way the numbered room clue works is the first digit inside the grid, basically touching that clue, tells you how far away to go. So we count 1, 2, 3, and then we place that digit there, the imaginary digit we're imagining, place a 2. So because we use 2 cells to sum to this 4, that 2 is now placed where this digit says to place it, 1, 2, 3. So it's a kind of an interesting interaction, and that's only for the ones that go outside the grid. So we have 1, 2, 3, 4, 5 numbered room clues that we have to figure out the digit for, and then use that with our numbered room clue. All right, sounds complicated, but if you're familiar with numbered rooms already, and you're familiar with like X sums at least, it's kind of a combination of those, a little variance on that. All right, well, let me know you did. Skipping ahead a little bit, those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay. I'm trying to figure out where a good place to start is. Maybe this 12. So, because we know that, well, I can explain why, but you have to use at least 3 digits to sum to 12 if you can't repeat. These are never going to repeat digits because they're all in the same column or row. So if you think about it, trying to add to 12 in 2 digits, you have to do 6 plus 6, and that would be 2 6s in the column. That breaks Sudoku rules. And so we need to use at least 3 digits, but we can't use more than 3 digits because that's the end of the puzzle. That's the edge of the grid. And so this is a 3, and then these will add to 12. Now we could think about, okay, how do we add to 12 in 3? What are all the ways? Let's exclude the ones that include a 3. But an easier way to think about that would be the outies in this case, because the outies are a smaller number of digits. So, and we know a 3 is involved. So what do I mean by outies? Well, what do these sum to? Well, we know they sum to 12. That's what the clue is forcing. And we know this is a 3. So we know that the total sum of these 4 cells is 15. 12 plus 3 is 15. We also know the total sum of the whole column is 21. 1 through 6 sums to 21. Therefore, these 2 digits here sum to 21 minus 15, which is 6. So these 2 sum to 6. So they can be either 1, 5 or 2, 4. Now, I think that affects this numbered room clue here. We don't know what the numbered room digit is, but I do know that it's not going to be a 1. It's going to be, to add to 10, it's going to be at least 2. But we're not, okay, it can't even be 2. So I'm thinking about the combination here, right? This digit both controls the numbered room clue and it controls how we're summing to 10. And so if it was a 2, then we would have to sum to 10 and 2 here, but we can't use a 6. So that's out. So it's got to be at least a 3. But it can't be the 3 either, because if it was a 3, then it's telling us, hey, this digit here tells us where the 3 is in the column. We already know where the 3 is in the column. It's right there. The problem is that would mean this would have to be a 3. So this is kind of a restriction with numbered room clues, is you can't have the numbered room clue in the same distance away as what it is, because it would need to go in 2 spots. I explained that poorly, but hopefully you understand. And so you can see this example here. If our numbered room clue was a 3, then we would have to put a 3 here in order to clue that 1, 2, 3 away was a 3, and that would be 2 3s. So it's not 2, it's not 3, and 4 would be our maximum to sum to 10. Because 1, 2, 3, 4 is 10, and 1, 2, 3, 4, 5 is 15. That's, I guess, simple way to explain that. And so this has to be 1, 2, 3, 4. That's the point. There's only one way to sum to 10 and 4. It's the minimum digits, 1, 2, 3, 4, which means these aren't 5. This is a 2, 4 pair, and then this is a 1. All right, well, that's handy. That tells us what this is 5, 6. So just to double check, 1, 5, 6 does add to 12. All right, I think we're doing well. Let's think about this numbered room clue. It's a 4. So you can never put a numbered room clue, whatever the clue is, you can't put it next to itself. It's a similar problem to what we had with the 3. If we tried to put a 4 here, then that's telling us 4 away, we need to put another 4. And not only is there a 1 sitting there, but we already have a 4 in the column. So 2 problems. So this is 2 and this is 4, and that makes our numbered room clue. Well, we already knew it was a 4, but yeah, that fulfills it. All right. I'm trying to see if this flows into another clue. We have a 5, 6 on this 12. That's pretty big. I don't know if it's big enough to do anything. We have this 4 that we haven't looked at. Okay, so normally you could do a 1 here and then just say 1 cell adds to 4. That's a 4. But the problem is if there's a 1 here, then this 4... Oh, no, sorry, that works just fine. I was thinking about that backwards. I was thinking about a 1 here. A 1 here doesn't work, but a 4 here would place a 1 here, and that does work. So that case does work. Okay, I was thinking it didn't, but it does. All right. So the other case is if this was a 2, then this would be a 1, 3 pair. And actually, this can't be a 1. So I guess my point is a numbered room clue can't be a 1 unless the clue itself is a 1. If the clue itself is not a 1, say the clue was a 2 in this case, then this is telling us to place the 2 right here. But there's already a 1 there, right? You can't place 1 and a 2 there. And so if this was a 2, this would be 3, this would be 1, and the 3 would tell us to put a 2 here. So both of those seem viable. So this is a 3 or a 4 is basically all I can pencil. All right, well, what else can we do then? Is it the 11 perhaps, or the 9 with a 4? So we could definitely do 2 with a 4 here and then a 5 here. That's viable. That would add to 9. What if this was a 3? We'd have to have these add to 9 with a 4 and without a 3. So these two would add to 5 without a 3, and that's actually not possible. We would add to 5 without a 3 or a 4. And the only ways to add to 5 are 1, 4, and 2, 3. So I guess there just isn't a way to add to 9 in 3 cells using a 4 but not a 3. So yeah, that makes sense. And so actually this has to be 2 and 5. 2 cells to add to 9. Where do I want to go from here? Well, we placed a 2 here. Oh, I think I remembered one of these cases placed a 2. Yeah. So if this was a 2, this would be 3 and 1, and it would place a 2 here, a 2 here, and that's 2 2s in the column. So that's no good. Basically, if this was a 2, the numbered room clue would force us to put a 5 here, and that's no good. So this is a 4. No, sorry, this is a 1. This is a 4, and that places a 1 here. Okay. Who's next? There's a 4 in one of these two. Is that helpful? Well, if 12 and 4, is this viable? Okay. So if we did 12 and 4, we know what all of these digits are. What would be the outie? So this would be 12 plus 4 is 16. And to get to 21, we would need 5. So this would be a 5. So if that's 4, oh, but we have a 5, 6 pair here, so that doesn't work. Okay. So what I'm saying here is if this was a 4, say this was a 4, I'll just fill it. If this was a 4, these add to 12, which means these add to 16. The outie to get to 21 would be a 5, 16, 21 minus 5. Oh, sorry, 21 minus 16 is 5. But the 5, 6 pair prevents this from being 5. So that doesn't work. So the 4 goes here, and then this is a 3, because 3 is the only other option to add to 12. Okay, and so now we know, I mean, I guess 7 is the outie. Does that make sense? Yeah, it does. No? Oh, actually, no, we need to get to an outie, and this is another outie. Sorry, I got confused. Now that this is a 3, these add to 12. These add to 7. 12 plus 7 is 19. So we need a 2 here to finish our outies. So yeah, these add to... These should add to... I was going to say 11. They add to 9. No, 9. I don't know why I thought 12 plus 11 was 21. 12 plus 9 is 21. Yeah, and these do add to 9. Okay. I confused myself. I probably confused you in the process. All right, so I apologize for that. There's a 2 on one of these two. 3 is somewhere up here. I don't even want to mark that. There must be like another clue I can... maybe I should think about these 7s and 11s facing each other. So, yeah, let's think about this. So 7 plus 11, the first thing we want to do is add them, is 18. Now that's not 21 or higher. So that means that there have to be outies. Like there have to be some cells that aren't involved in the 7 sum or the 11 sum. So somewhere in between here, we don't know exactly where it is. There's one or more cells that aren't part of these sums. But because this sums to 18, those cells will add to 3. Now, I think that's got to be this 3 here, because otherwise we'd have a 1 and a 2 as an outie somewhere. But the 1 is here, and we can't do the 1, 2 this way. So it would be a 1, 2 this way, and the 7 would only get 1 cell, which we can't do. So yeah, I think I've proven that this 3 is our outie. So the 11 uses 2 cells, so that has to be 5, 6. This is the 6, this is the 5. And then this is going to use 3 cells, and it's just the 2 and the 4 left. That works. And this 2 looks down, telling us that's 4 and that's 2. Now, I think that we can just double check our numbered rooms, but we didn't actually need them. So this was in 3, so this 4 tells us the 3 is there. And this is in 2, so this 5 tells us the 2 is there. All right, perfect. So maybe I could have done that earlier and saved myself some earlier logic, but that's okay. I think we're doing fine. This 4 looks down, that's 2 and that's 4. This is a 1, 2 pair. That's a 1, that's a 2. This is a 1 to finish the box, and these 2 are the 3 and 6. All right. In this row, we need 1, 3, and 6. The 1's in one of these. Maybe I should look at this 12. I think this 12 is the only one I haven't looked at. So 12, again, is in 3 or 4. Those are the only options. I wonder what we can do with that. Let me just actually pencil this. This is 3, 5, 6. I wonder if that helps. Oh, we need a 4 in this box, and so the 4 goes here. And so whatever our length is placed here, and 5 and 6 are too big. So this is the 3. This is our length. Kind of doing the numbered room backwards. Whatever's in slot 4 has to be the length of this sum. So it's a length 3, so we're going to do 4, 6, 2. All right, that's 3 and 6. That's a 1. These are not 3s. I think it's Sudoku from here. We need a 3, 5. This is a 3, 5, 6. This is a 1, 5. This 1 tells us that's 5. That's 1. This is a 6 and 5. What is this one? 6. All right, we get the 3, 5, 6, 5, 3, and we're done. All right, this was a neat puzzle, Gene. I really liked how it flowed, and I really liked how using the outies was really helpful, and especially this opposing 7 and 11 was really neat, especially once we had already placed the 3, and then also had placed the 1. It really forced this 3 to be the outie for 11 and 7, which gave us a nice boost. Really neat ideas in this puzzle. I think my only feedback would be if it was possible to actually fill in these outside clues. I think that would have been helpful, just for note-taking purposes. Anyway, let me know how you did, and if you enjoyed this, why not leave a like, subscribe, and a kind comment below.